SQL paper. Associated with the machine learning and mechanical engineering, current trends and future perspective. Where we are using the research So here author will be focused on the use this paper to predict the maintenance of the system, and many applications are discussed in this paper. It may actually is not readable to the you also. And for implementing this different models, they use the different algorithms. Just move to the next page. This is a taxonomy of algorithms: artificial intelligence, machine learning, and deep learning. You can see the middle machine learning. There are three types: supervised learning, unsupervised, and reinforcement learning. And if we combine the supervised and unsupervised, then we call the semi-supervised. So these are our models used for different purposes. For classification, use the SVM model, then Davis bias, then k-nearest neighbor. Scroll down. Then discrimination analysis. Then these models are classifying, make the different classes based upon the features. Then next is the regression model. Because this we are going to learn in a machine learning models now in the next. So in regression, there is the SVR. This is the support vector machine regression. Here regression, we know the line formula. Okay, means like regression or linear model. You go from the SVM, then this is the, we can say the ANN. This is the previous part of the CNN, artificial neural network. Then decision tree, then linear regression, then GNN, general linear model, and GPR. This is a Gaussian process regression happens. Then assemble learning. Again, assemble are two types. One is the vector. The third one is the clustering. Clustering means make the cluster of a particular or same like features cluster, and based upon the cluster, these algorithms are used. One is the hierarchical model, then K mod or K nearest or K means, and fuzzy C model. These models are used for, means these are the models based upon the what purpose you have to choose this model. Not model is nothing but the algorithms. Then corpoidal model, then Gaussian mixture, then the natural or networking type model. Then reinforcement learning. What it is learning means it is best for the feedback. Your system learn on the feedback. To take the example, simple example, when we teach your when we teach the small kid to drive the bicycle. Okay. Maybe you are teaching them, but from the feedback, how to balance, how to put the force on the pendulum. He learn from itself. Means you are getting some feedback, or sometime maybe collapse, or sometime he hurt. But learn from the feedback, and he after few hours or few days he start trying the bicycle code. Means it is a feedback based. Or depends upon the feedback, model change, and again is predict the output. Then here in a reinforcement learning, then simulated analyzing, then distributed value function, generic algorithms. Okay, used for that purpose. Okay, these algorithms mainly used for the depends upon the what type of data set you are using. Based upon the data set, you have to choose the model. And there are many examples will be discussed here. This is actually the predictive maintenance, how data is collected is focused on this paper. Means there are system sensors, then sometimes the expert data. So there are many applications here. Data is acquisition, means collecting the data first place. Second is data integration and storage. Means once data is collected, then store into the same place. Then apply the model or predictive maintenance model or that model training and validation. Our training means once you train the model and then later on validate. Validate means you are validating the particular model output. Then once your model is trained and validated, then you deploy the model for product development or for use from the users. And then maintenance of the, and these maintenance are different types of maintenance. Okay, there is the maintenance of the reactive maintenance, preemptive maintenance, and primitive maintenance. These are the different stages. This is the diagram there. Then you can see the how data is collected. Okay, data is collected and based upon the time period. How the time period, based on the time period, the cost is increased. The system is downtime, which affects on the cost. There is the diagram, or you can say the analysis, cost with maintenance. How the effect of the cost. If you take the proper maintenance, it requires the less cost. This is the actual output of this paper. I think I stop here, and next session we will start immediately. Thank you.
Good afternoon, everyone. Thanks to all the participant guests and experts for participating in this program. So first of all, I would like to thanks to our today's guest, Dr. Sharmila. She's working with Miss Wadia College of Engineering. She's having experience of 25.8 years. Okay, and again, which is in teaching field. Apart from that. Like she'll be sharing a valuable knowledge on the topic, types of learning models in machine learning. Okay? And again, I would like to thanks to our treasury member of Svcet, Mr. Sachin Chauhan sir, and our academic dean, Mr. Balram sir. Apart from that, I would like to request to start the session. Thank you.
So good afternoon everyone. I know that it's a post-lunch session and it's very difficult to attend also as well as to conduct also. Okay. Still we'll try to make it interactive and we'll just go for theory for some time only. After that we'll take a lab session. Okay. So you are all from means first year engineering or first year diploma? Or it's a mixed crowd is there? First year diploma? Engineering. Okay. So ML still now it is not there in your syllabus. Okay. Is it there in your syllabus? No, no. This college is affiliated to SVP. What about Python? Is it there? Okay. So we'll do that ML programming with the help of Python. We'll just go for simple code. So easily you will able to implement it. Sir has one more connector. So do you want to discuss S? Up till now you have a clear idea now what is ML, machine learning. Yes or no? So if you just go for that paradigms of that machine learning, initially AI come first, artificial intelligence. Subset of artificial intelligence is a machine learning. Okay. Subset of machine learning is a deep learning. Means if you just draw the diagram, set diagram, then deep learning come first, after that ML, after that artificial intelligence. Okay, this kind of is there. So ML is a buzzword nowadays. In companies also there is a specific means separate post are there ML engineer. Same way. Okay. So ML you can use it everywhere. Which are the applications are there? See, in the third year you will do some projects as well as in the second year itself. In that NEB program you will do the project. So whichever the models are there, you can train it with the help of ML. So definitely you will get very good result. Okay, we'll just see that how this is a different, ML is a different as compared with that your traditional programming. Am I audible? Am I audible? Okay, chalo. So, my topic for today's lecture is that is there need of mic? Without mic, am I audible? Yes. Okay, so no need of. So, topic for today's session is that your types of learning and models of machine learning. Okay, in the morning session, you are familiar with that. What is machine learning? Okay, what are the basic concepts regarding that machine learning? Now we'll move forward with the types of learning, models of machine learning. Okay, so machine learning. So what is ML? S. What is ML? See, there are n number of definitions are there. In 1987, Mr. Tom Michel, he had written a book, Machine Learning. Okay, so according to that, his book, this definition is there. So there are a number of definitions are there, but basic concept is same only. So machine learning, you can say that it's a subfield of artificial intelligence. It's a subfield of artificial intelligence. Enables computers to learn from data and experience. It's very important. It enables computer to learn from data and experience. Both the things are important. So whenever you do that machine learning program, you will need data as well as the experience also. In traditional programming, only data is sufficient, but here we are going to add the experience. Okay. After that, without being explicitly programmed, then instead of human programming writing explicit static instruction for every possible scenario, the machine learning uses statistical algorithm. There are n number of algorithms are there. There are n number of models, various types of techniques are there. With the help of that, these are all statistical algorithm to identify pattern in largest data set, build a model and automatically improves its performance over time as a process more information. Okay, so you can means what is the takeaway from this definition, that machine learning is a subset of AI. This is the first thing. Second thing is that these machine learning programs learn from the data and experience. Along with the data, we need experience also. Over a period of experience, it will means whatever the efficiency of that model becomes good. Okay. Our aim is always we are interested for 100% efficiency. So this is how it's different from traditional programming. In the traditional program, for example, without machine learning program, we will do some addition of two numbers. How will write that addition of two numbers? We will take that two numbers input. Okay, we will ask, then I will just use that add instruction and you will get output. Yes or no? Okay, so in the traditional programming, what is the input? Input data. Means for example, we want to do the addition of two numbers 2 and 5. Okay, so input data, what is our input data? 2 and 5. Okay, after that, rules and instruction you have to give as an input also. What kind of rule you are going to give here? That addition, do the addition of 2 and 5. Add, you will just use the add instruction, otherwise you will just add that plus sign there. Whatever that, if you take the variables, then a and b, then output is the c is equal to a plus b. Plus sign, automatically that system means analyzer will analyze and it will do the addition. Okay, so in traditional programming, input is the input data as well as the rules or instruction. Add a comma b if you will do that machine level programming in microprocessor. Simple in other language, that a plus b. Okay, what kind of output you will get it? That 3 plus 5 output is 8. Yes or no? 3 plus 5 output is 8. But this is not a case in machine learning. Okay, in the machine learning, your input is input data. What is our data? 3 and 5. Our data is a 3 and 5. Okay, but along with that, you have to give the desired output also. Means we will give the input as a 3, 5, as well as we will give the 8. 8, this is output also. These two things are input. Okay, in machine learning algorithms and all these things. And what is the output of that machine learning? You will get it rules. Okay, so it will just learn that input are 3, 5, output is 8. So what kind of means coordination is there in this input and output? Okay, 3, 5, 8. So it's nothing but the addition of 3 and 5. So you will get a rule as an output. You will get a rule as output that add these two numbers, then you will get an output. Are you getting it? So in this way, machine learning program and your traditional program, there is a difference is there. In the traditional program, you are getting the desired output as an output. Okay, but in machine learning, as an output, you are getting that rules. And once you will, so this is called the training. Once you train your machine, which are that rules are 100% efficient, then which it will work on that unseen data also. So next time you will do that 11 plus 11 2, it will give the output 13. 17 3, it will give the output 20. Are you getting what is the difference between machine learning and traditional programming? Okay, so here for the first program, here 3, 5, and rule is that do the addition, and you will get output that 8. Here output is at 3, 5. Desired output also you have to do as an input. So 3, 5 and 8. 3, 5 and 8. Okay, and as an output you will get that 3 plus 5 is 8. This is the addition. This is the addition. This kind of a rule you will get it as output. Is it clear? Okay. So in machine learning, obviously you are going to, in definition itself, it learns from the data and as well as from experience. Data and experience. So you learn from, means here you will need data processing, data pre-processing. Okay, which of that data you have. Okay, you need to do that pre-processing. You just imagine that, for example, gold mining mills are there. Okay, so directly you will just dug and you will get a gold. Is that no, na? Along with that gold, means rough material is there, too much soil is there, some other substances and all these things are there. You need to do that pre-processing. Then out of this much of material, you will get just 10 gram, 20 gram gold only. Okay, this is called as a pre-processing. You have to do that pre-processing and then you will get a final output. So same way, huge data is there, you need to do that pre-processing, and after doing that pre-processing, whatever your expected data is there, that thing you have to give it as an input to your program. Okay, so in machine learning, data pre-processing is there, as feature selection. Whichever your data is there, we are representing with the help of features. Okay, for example, you just take a supermarket example. You are going to represent data of supermarket. So you have to just represent in the Excel format. Okay, but in the Excel format, for every column means, for example, item name, first serial number, then after that item name, okay, some item description, item category, okay, which comes, it's a cosmetic product or it's a medical product or something, item price, expiry date, all these things are there. And after that, in your means your rows means your records, okay, all records are there and all the description is there. So this is nothing but that, what are that column name, this is called as a features, okay. So feature selection, obviously whenever, for example, you just imagine that in the supercomputer market data, okay, n number of features are there. So it is not required for every time you have to deal with that all the n number of features. Okay, for example, 100 features are there. If you are going to deal with the help of 10 features only, so you need to apply the feature selection. Okay, out of 100 we'll just take an important 10 only and we'll do that programming. Then model evaluation. You need to train your model, you need to test your model and do that evaluation part. Okay, model training also. First model training and after that model evaluation. You need to train your data. We will see all these things in detail with the help of example, don't worry. Okay. So in the machine learning, problem statement, after that data collection, you need to collect your data first, okay. After that data cleaning, because some missing values are there, some null values are there, you have to use a separate treatment for missing value, null value, some redundancy of data is there, repeated values are there, etc. Okay, so you need to do that data cleaning. Then after that, data analysis and exploration. So out of that, what kind of data you are going to use it, okay, which one is useful for your program and all that, that is the data analysis and exploration. Then data modeling. So this is our today's topic, that data modeling. In the machine learning algorithms means ML learning types and modeling. Okay, so data modeling and at the end optimization and deployment. So whatever the output you are not convinced with that output, again you need to repeat this all the steps. Okay, again train your model, just check that what kind of efficiency you are getting. For example, it may happen that in the iteration 1 you will get a efficiency 70%. Again, whatever the experience you will get it, again that data and that experience and all these things give that input, train your model. Next time it may happen that in the iteration 2 you will your efficiency is 80%. Okay, again repeat the iteration. At the end it may happen that you will get a efficiency 99%. Okay, if you are convinced with that 99%, then this is called as optimization and deployment. Okay, once you are convinced with that efficiency, then you can deploy that model. So why should we learn the machine learning? Because it enables the computer to learn from the data. Okay, so, and as well as it improves the problem solving skill, machine learning, it opens the high demand career opportunities. Obviously, just now I said that ML engineer is a separate position is there in the software industries, and it powers everyday technologies. Okay, that's why, and along with that there are n number of advantages are there of the machine learning over traditional programming. That's why you have to, means we should know the machine learning. If we just go for example wise, there are a number of examples are there. I have listed something only. ML powers many everyday technologies such as recommendation on Netflix and Amazon. For example, if you search something on the Amazon, okay, and for example today I'll search something, for example watches, or something, okay, and I'll not buy it. I'll just keep it as it is. Don't worry. I'll just close that Amazon web page and all these things. After 2 days, again they will give me some more ad regarding to that watches, different variety and all this thing. So this is nothing but a recommendation. Okay, so how this will happen? Just because of machine learning, whatever the search will do, they will just save that searching pattern, and whatever that searching pattern in our account, so next time whenever we'll log in, okay, so same kind of a searching pattern, they will just give the output regarding that searching pattern. That's why that ad is also similar to that regarding whatever the means watches regarding ad with some offer and all these things, this will come. Okay, this is the recommendation on Netflix as well as Amazon also. In the Netflix, if you search something, so next time, for example, if you search drama kind of movies, okay, so next time they will offer you that drama kind of movie initially. Okay, in this way, this is a recommendation. After that, voice assistant, Google voice assistant and all these things. Fraud detection, there are means your credit card fraud detection, then in number of fraud detection in that your financial industries you can identify with the help of machine learning. Then medical diagnosis and self-driving cars, this is also example of machine learning. In the self-driving car, that fixed program is trained. If this one is there, means for example image processing and all that sensor, they are all coordinating with each other. Whenever that car will drive, that fixed path is there. According to that, if some object will come, then it will take a decision that to stop there, otherwise turn from this side and all that thing. This is nothing but a machine learning application. Okay, so there are n number of machine learning applications are there. So why now we start with our today's topic, learning models. Learning models. Okay, so learning models of machine learning. But why we need a different learning models? Because see, different type of data are there, different type of experience. See, data, you just tell me the types of data. Up till now, what kind of data you up till now, which kind means you have deal with how many kind of data or which kind of data? Simple text format. After that, if input is in that images, for example your x-ray detection and all that thing, medical images, so what kind of data is there? That is all that images. Okay, if you are going to do with that your document classification, then files and all that things. Okay, if text classification, then simple text format. Okay, if it's a financial data, then numerical data. Okay, if it's a movie recommendation system and all that, then string regarding data, numerical, nominal data and all that thing. Different kind of data are there, different kind of experiences are there. So obviously it's not that the simple one model will be there and it will do all that thing. That is not expected. Na? So different kind of data are there. That's why you need a different kind of model also. So need of a learning types of machine learning arises because different problem require different ways of learning from data. Different problems are there. You just check that. For example, in previous slide we had taken that the recommendation on the Netflix and Amazon. Recommendation on Netflix and Amazon. Here, whatever search is there, that is your data. Whatever your search is there, that is your data. Okay. After that, voice assistant, audio files will be the data. After that, here fraud detection, which of the financial regarding data is there, credit card number, amount and all that, bank number and all that, that kind of a data is there. Okay, medical diagnosis, in the medical diagnosis your image format data is there generally, all that image format reports and all that is there, report. Okay, self-driving car, again image processing and here you will get a shortest route and all that image processing you will need it here. Okay, so different kind of data, that's why you need a different learning models. So no single approach fits all the situations. So there are mostly 4 types of learning models are there. So first one is that your supervised learning. Okay, first one is the supervised learning model. Second model is that your unsupervised learning model. Third model is that your semi-supervised learning model. Fourth, semi-supervised and self-supervised learning model. Okay, and fourth one is that reinforcement learning model. We'll just go through this all the 4 types. Okay, and in the practical session also we'll do one program for supervised, one program for unsupervised in this way. Okay, is this diagram is visible? Last bench. Okay. So what is the, see here, label data is there, and what are the labels? Hexagon, square and triangle. Means this data is there. This is the input data. You know now, always now you have to always keep it in mind that what is the input for machine learning programs? What is the input? Chalo, fast we have to finish this theory also as well as we have to finish our practical also. What is the input for machine learning programs? Okay, leave it at machine learning. What is the input for traditional program? Input and Rules, very good. And what is output of traditional program? Desired output. In machine learning program, what is input? Very good, very good. Input and desired output. Input and desired output. And what is the output? Rules. Okay. Now see here, in that supervised learning, label data is there. Label data. Okay, and these are the labels are there. Label means output only. Okay, means see this kind of a thing is there, then that is called as a square. If this kind of a 3 sides and this is there, then that is called as a triangle. Okay, if these 6 sides are there, then that is called as a hexagon. So this is my input data along with this output also. Input data and along with this output also. Okay, now these both the things I will do to that my machine learning algorithm. This is called as a model training. I will train the model. How I will train the model? If 4 sides are there, then call this thing as a square. If 3 sides are there, then call this thing as a triangle. If 6 sides are there, then call this thing as a hexagonal. Okay. In this way, I will train my model. Okay. In this way, I will train my model. Then model will get trained and all this one. Okay. And whenever the model will get trained, and I am convinced that okay, I am happy with this motto, the training efficiency 100%. Okay. Then I will give some unseen data. Unseen data. I'll just give that in this kind of. I'll not give the label that for that data. I'll give some unseen data. So that model will predict that. Okay, if this is there, then model with the help of training, that model will predict that this is a square. With the help of the training, whatever the training is there, that model will predict that this is a triangle. Are you getting it? Okay, this kind of a learning is called as a supervised learning. In supervised learning, along with that data, we are giving labels. So labels means nothing but output. Label means nothing but output. Along with that inputs, we are giving that labels. Label means nothing but output. Okay, and then based on that we are giving the training. And then after that, once our model will get trained, we'll give the testing data as the input, and then model will predict and it will give that correct output. Is it clear? This is called as supervised learning. Okay, just take an example, supervised learning. For example, teacher will teach you that particular subject. Okay, and based on that, whatever the classes and whatever the knowledge you will get it throughout that classes. Okay, you will appear for the paper and you will write a paper. This is called as supervised learning. Okay, means you have that input, and as well as teacher has taught you that if this question is there, write this answer and all that, and in this way you have to write it, all the details. Okay, this is called as a supervised learning. Next type is that your unsupervised learning. What is there in that unsupervised learning? Just check it here. Unsupervised learning. See here, only input raw data is there. Input raw data is there. Labels are not there. Only input raw data is there. See here, we have to mention that this is square, this is triangle, this is hexagon. No, only input raw data is there. Okay, then interpretation. See, this one more step is here, interpretation. An unsupervised learning algorithm will just go through that all the data and they will interpret that. If this one is there, then it should be called as a square. Then this one is there, then it should be called as a triangle and all that. Okay, so whatever the nature is there, whatever the behavior is there, okay, it will take decision. If this kind of a figure is there, then we will call it a square. If this kind of a figure is there, then we will call it a triangle. Okay, in this way, in unsupervised learning, with the help of some algorithms, methods, and some techniques, you have to train your this thing. Okay, and means you will get a label. That is a model training. Label means model training. Then same again, you have to do that unseen data for the processing, and it will process, and final output you will get it as a square and triangle in this way. So what is the difference between supervised and unsupervised? In the supervised, labels are attached with your input data. Here in unsupervised, labels are not attached. Labels are not attached, but with the help of algorithm strategy, we have to generate the labels. Is it clear? Okay. Next type is that your semi-supervised learning. Semi-supervised. Okay. Semi-supervised and self-supervised also. Okay. What is that semi-supervised? It's a combination of both supervised and unsupervised. It's a combination of both. In the supervised, labels are there. In the supervised, labels are not there. So it's the same thing is there. Two types of data are here. See, first type of data is there. Large amount of unlabeled data. Means data is there but labels are not there. Large amount of. And some portion of labeled data. Some portion of labeled data. Means for example, you have 100 records. And out of that 100 records, for example, 80 records without labels and 20 records with labels. Okay, now what this supervised algorithm, semi-supervised algorithm does? Okay, based on that labeled data, it will some apply knowledge, vagara something, and it based on that it will try to generate a data for this one also. It will just try to generate a data also. Means finally you will have that pseudo labeled data. Okay, means it's not a correct, means all this is pseudo labeled data. Okay, considering that both the things. Okay, so after that this line is also here, but it is not visible. Yes, this line is there just because of light is not. Okay, then you have to do that unseen data. It will train. You have to do that training and all that. Then unseen data you do as a input again, and then you have to train model with a, it will just describe that this is nothing but a square, this is nothing but a rectangle and triangle and all this one. Okay, so what's this here? It's a semi-supervised is a combination of two supervised as well as unsupervised. Some major portion is that unlabeled data is there. Small portion of labeled data is there. In semi-supervised algorithm apply some knowledge, some techniques, vagara, and it will try to generate data for major portion also. Okay, so it will just with the help of its knowledge, it will generate the data for 80 records also. You have already 20 labels are there. Okay, in this way, what that nothing but that 100 all that record is that pseudo label data. Okay, pseudo label data based on that train your model. Okay, and give the unseen data as a input again. Then your model will give you output that whatever the expected output, that this is nothing but square, this is nothing but triangle in this way. Is it clear? Supervised, unsupervised and semi-supervised. See, for these are the three types of learnings are there, and for all this learning different algorithms are there, different methods are there. But before that you should know the actual means you should able to differentiate these three things. Okay. After that, fourth one is that your reinforcement learning. Reinforcement learning. Okay, what is this reinforcement learning is that? See, do you feel sleepy? No, na? We'll just go for some theory part only because that is necessary. We'll implement that unsupervised learning algorithm, but you don't know the basic concept of unsupervised, then what's the means logic to implement that code, na? Okay, so next learning is that your reinforcement learning. Reinforcement learning, see what kind of things, baby is there, he is sitting. Then he will do some action, he will do that crawling. Okay, it may happen that after that crawling, mommy will become very happy, and as a reward, mommy will give a bottle of milk to him. Okay, this kind of a scenario is here. Now see what is that reinforcement learning. Reinforcement learning is a machine learning paradigm that focuses on how agents means here baby we are considering as agent, how agents learn to interact with environment, this kind of environment, that baby is there into that room. Okay, that is environment. So how agent learn to interact with an environment to maximize cumulative rewards, okay, this is called as a reinforcement learning. Okay, let it be, leave this example apart. Are you familiar with that online game and all that things? Online game, that small snake wala game and all that. Okay, if you go next stage, and if you do something, if you pass that stages, then you will get a reward. You will get reward some 100 bonus, 200 bonus, or that gold bag, something. Okay, and if you do some mistake, then you will get penalty also. Okay, it's based on your action. What kind of action you will do? Based on that, you will get reward or penalty. Okay, reward and penalty. So what will happen whenever you will get reward? You will you will move ahead. If you will get a penalty, then you have to come back again. Whatever that. For example, you know that Marathi it is called as subsidy. Okay, whatever that your actions are there, then it may happen that you will go, and if that means head of that snake is there, then again you have to come back to that your original position. Okay, otherwise if you will get that ladder, then you have to directly move to that next position. Okay, same thing is there, award and penalty, reward and penalty. Okay, so for example, if we will play, then we are an agent into that environment. So how agent is interacting into that environment? Based on that his action, it may be reward or penalty, next position is there. Okay, otherwise you can just imagine the chess game. Chess game मध्ये काय असतं? Chess game, whatever your moves are there, that based on that your next move is there, no? Whatever your decisions are there, based on that your next move is there. Otherwise, if you take that wrong decision, you may come back also. Okay, it will take that correct decision, intelligent decision, considering that your next party in front of you, then you will get that correct decision. That is nothing but that reinforcement learning. Reinforcement learning means it learns based on the feedback. Whatever the feedback you will get it of your previous action. Of your previous action, based on that your next move is there. This is called as a reinforcement learning. See, I am reading this definition again. Reinforcement learning. Now see, what is this example? This baby is there. Baby we just call as an agent now here. Baby is sitting. Okay. Baby is into that room. Means it's in that environment. Okay. So what kind of action is doing? He is a crawling. Okay. So as a crawling, if he will crawl something up to that particular distance, then his mama will give him as a reward milk of bottle. Okay. So this is a reward. This is a reward. So what is the reinforcement learning? Reinforcement learning is a machine learning paradigm that focuses on how agent learns to interact, how agents learns to interact with an environment to maximize the cumulative rewards. This is called the reinforcement learning, or simply in simple language we can say that reinforcement learning learns from the feedback on previous stage. Based on that feedback on that previous stage, its next move is there. Okay. The same diagram is there. See, input data is there. After that is kind of environment is there, agent is there. Whatever the agent, it will do the actions, selection of algorithm and all this one. If best action is there in that environment, then they will get a reward. Okay, and again that reward is also comes as a feedback to that agent. In this way, all this will repeat again and again, and they will just try to maximize the gain, cumulative gain. Okay, and as an output you will get it that, for example, this kind of a data is there. There are three types are there: squares are there, stars are there, two color stars are there, and all these things. So as an output you will get it that separated means separate things means all that star, all that square, all that other color star, and all this one. This is the output. Is it clear? Reinforcement learning. So these are the four types of learnings are there. So supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. This deep learning is a fifth type, but that is not included in your FDP deep learning. Okay. So if you go for paradigms of that AI, then artificial intelligence first. After that, subset of machine learning is a subset of artificial intelligence. Then after that, deep learning is a subset of machine learning. Deep learning is a subset of machine learning actually. Okay. So now we move to that your supervised learning. Is it clear now? Should we revise that? What is that? You just tell me yes or no. In supervised learning, inputs are labeled. Input along with that input labels are attached. Yes or no? Okay. In unsupervised learning, labels are not attached. Okay. With the help of algorithm, some method, with the help of connection, you need to draw the labels. After that, semi-supervised. Combination of both, some portion of labeled data, some portion of unlabeled data. Then you have to again apply some knowledge and try to gain the label for unlabeled data also, and then that would be the training. Reinforcement learning, it's completely different. It's based on that your whatever the feedback, it works on that whatever the feedback of your previous stage, it will take the next move. Deep learning is okay. So in that supervised learning, regression and classification, those two types are there. So today we'll do one assignment or one program for regression, one for classification. In unsupervised learning, clustering and dimensionality reduction. This one is there. Then in semi-supervised, self-training, low density separation and graph-based algorithm. These are there. Then in reinforcement learning, dynamic programming. Then your Mento-Forleo methods and heuristic method. These are there. Okay. And in deep learning, CNN, RNN is there. CNN, RNN is not there, but this remaining portion, some speaker will also cover into that their respective lectures and all that. Chalo. Now, how supervised learning works? Yes. Now we talk in terms of machine learning language only. Okay. So whatever the input is there, input we will just call this thing as X. Okay, and output we'll just call this thing as Y. Okay, so input is see in that supervised learning, input data you need to collect data first. Whatever the kind of data is there, you need to collect data. You need to do that data labeling. Okay, labels are not there, then you need to do that data labeling. Then train the model. Okay, actually in the supervised learning, obviously all data is a labeled data only, but whatever the missing things are there, something you need to do that data pre-processing. train the model, test and validation, and prediction on new data. This is in your supervised learning. Okay, just take example for email spam detection. Email spam detection. So what kind of data, input data is there? Email text. You have to just identify that email is a spam or not. Okay, so what is the output here? As the output you will get it that email is spam, email is not spam. Okay, email is spam, email is not spam. These are the two outputs you will get it. Okay, so input is that your email text and labels are that your spam or not spam. Two outputs means two labels, spam, not spam, spam, not spam, in this way. Okay, so email text is, for example, win cash now. Okay, so in the machine learning we have to train learning algorithm in such way if this kind of words are there in the email, win cash now, vagara vagara, this is not a this is not authentic mail, so you just attach this label as a spam here. Meeting at 10 a.m. it's authentic contents are there, then it is not a not spam, label is attached, it's not spam. So the model learns which words usually indicate spam. Okay, so in machine learning two actions are there, classification and regression. Okay, classification and regression. Always in machine learning, in supervised learning. In supervised means always labels are there, classification and regression. Okay. So in the classification, use when the output is a categorical class-based output. Two types means always output in classes. For example, S class, no class. You are interested for theory lecture, some student will say no, some student will say S. Means two classes are there, S, no. Okay. After that, pass, fail. If you will do that result analysis of your class, okay, only two classes. Some this 30% students their result is fail, 70% students result is pass. Only two classes, pass, fail. Okay. After that, disease, no disease. Okay, if your output is in terms of two classes only, it's called the binary classification. Yes, no, 0, 1, true, false, male, female. That is your binary classification. Okay, whatever the processing, but final output in two classes only, final output. That is called as a binary classification. Okay, after that your other than binary classification, for example, your program is that to identify the alphabet. How many classes will be there as output? To identify alphabet, how many classes will be there as output? 26 classes will be there, na? If this kind of nature is there, where classes at A class. If this kind of nature is there, then classes at a B class. So 26 classes will be there. It's called the multi-class. For example, identification of digits. How many classes will be there? Identification of digits. How many classes will be there? 10 classes will be there, starting from 0 to 9. Okay, 0 class means class 1, class 2, class 3, in this way. Okay, it means for example handwriting means your whatever the image analysis, whatever you have written on the check, that amount. Okay, so someone will write 1 in this way, someone will write it 1 in this way, someone vagara vagara vagara. But you have to train your model. If this kind of a structure is there, then classes has a 1. So as a digit classification, you will have 10 classes. So whatever that your input is there, but at the end you will get output in the 10 classes. Okay, so this is called the multi-class problem. Classification is there, but multi-class. Okay, classification is there, but only two classes. That is your binary classification. Binary classification or multi-classification. Then email spam or not spam. You just tell me that it's a multi-classification or binary classification. Output is a email spam, email not spam. Binary classification, because as an output you are getting two classes only. Okay. After that, disease diagnosis. Disease diagnosis means that person has a cancer or not. Final output yes or no. That is your binary classification. Okay. Then face recognition. Face recognition is a what kind of a which class problem? Face recognition, multi-class, multi-class. Okay. Then which are the algorithms are there in this supervised learning, decision tree, support vector, n number of algorithms are there. Okay. So classifier, you train your machine, you train your algorithm that this kind of a structure, elephant, this kind of a tiger. Okay. This classifier is there. If you give this out input, okay, so it will just classify this is nothing but the elephant class. Okay, in this way. Now second type of a supervised learning. Still we are with supervised learning only. Supervised learning means label are attached with your input. Okay. Second type of a supervised learning is that your regression. Okay. First type is a classification. Output is a classes, specific classes. Two class, then binary class only, multi-class, then multi-class classification. Regression. In the regression, you will get multiple outputs. You will get the multiple outputs. And then that type is called as a regression. Multiple output. For example, just take an example of this college. Okay, here a number of faculties are there. Okay, and their experience is different. Principal, dean, whatever that your HOD, staff, senior staff, junior staff, office staff, lab assistant, okay, peon, vagara, etc. All this one. Everyone's experience is different. Everyone's qualification is different. So obviously, everyone's salary is also different. Okay, so if you just write an algorithm for that, identify or calculate a salary for this college, then you will get n number of outputs. Okay, means it's not fixed salary, n number of. So this is that means you will get a multiple output, multiple output. So this multiple output is called as your regression problem. Regression. In the classification, fixed classes are there. For example, digit identification, whatever the input means only 100 records or 1 lakh records or 10 lakh records, final output is 10 classes only. Okay, but in the regression, you will get multiple outputs, multiple output. See what is the definition of regression? See, when the output is a continuous numerical value. See, when the output is a continuous numerical value. Salary is that your continuous and numerical value. So it is called as a regression problem. So output type is salary, temperature. Is that fixed? One temperature is only. The temperature time to time it changes. For example, in 24 hours you are counting or you are just displaying temperature. N number of temperature values will be there, na? -1, -2, or for example 8 degree, 4 degree, 15 degree, and all this 15 Celsius and all. Okay, temperature. Then house prices is how this house prices is a regression. For example, what are the factors are there which will affect on that house prices? That area, means in which location that house is there. Okay, what is the area of that particular house? What are the amenities are there? What are the amenities are there? Again, many things are there. Okay, so based on that, house prices are there. So house is also it's a regression problem. Multiple outputs are there. Continuous outputs are there. Okay. So which are the algorithms used in regression? Linear regression, polynomial regression, after that SVR support vector regression, etc. See, in this way this data set is there, regression and all this one. Function is there, you have to this blue color box means data, you have to use that input and other parameters, then you will get it at particular price for that particular house. Okay. So don't worry, we'll see example also, we'll solve some example also, classification and regression. Okay, and we will implement algorithm also for that in the lab. I don't know that how much time we will get it and how it is possible. Okay, so what are the, so is it clear? Supervised learning, what are the two types of supervised learning? Classification and regression. Classification, binary classification or multiple classification. In regression, again there are two types of regressions are there, linear regression and polynomial regression. We'll just see. See, linear and polynomial regression, okay. So what are the application of supervised learning? In healthcare, so just check it, healthcare, disease prediction, medical care, diagnosis, patient risk, email systems, spam detection, image filtering. See, this one you can do as a project. For example, with the help of dataset, you have to just download the dataset from the Kaggle Vagara and apply the algorithm and do the project for patient risk analysis using machine learning algorithm. Disease prediction using machine learning algorithm. After that, email filtering using machine learning algorithm. After that, for example, e-commerce regarding project, customer behavior prediction using machine learning algorithm. Okay, price prediction using machine learning algorithm. Okay, so these are the applications of supervised learning. Transportation, self-driving car, object detection is a supervised learning because we have to train that complete model with the help of all the labels also, and then it will whatever that unseen thing will come, it will work. See, self-driving cars are there. Actually, the USA, these are self-driving cars are there in the San Francisco. Route is fixed. route is fixed. Okay, so it's not that you will just ask them that will go there. No, fixed route is there. On that fixed route only it will work. Okay, and but they have the training of that all the object detection. Anything object will means anything will come in between, na? So completely that is the image processing only. If that object will come, then it will just process image processing. It will identify object and it will detect the object and it will take a decision again. What is that? Move in this way and all that. Application of supervised learning, then transportation, self-driving cars, object detection, traffic prediction is also this one. You are familiar with that Google Map and all that things. Okay. Then banking and finance supervised learning, loan approval, supervised learning. You can just do that loan approval. Credit scoring. Now you know the CIBIL score is very important. If you are applying for loan, okay, they will just check that your CIBIL score. CIBIL scores means that, for example, you are applying second time for the loan. So whatever your previous history is there, okay, for every month you paid that particular installment into that particular time or not. Based on that CIBIL score calculation is there. If your CIBIL score is good, then only you will get a loan. Or they will, it means whatever the amount of loan according to that your CIBIL score. Okay, so that is nothing but your machine learning algorithm. Then your fraud detection, education, student performance prediction. Nowadays, see, many apps are there. For example, if we just do this one, if we input all the performance, then what is my possibility that where I'll get the college, which college is suitable for me for this percentage and all that thing. Okay, that is a student performance prediction, attendance analysis, exam result prediction, etc., etc. Okay, now see, classification is there. I have taken this slide from the Kember book as it is classification. Just let me tell you, see how that classification is working, model training. Okay, just see this training data is there. See, in every machine learning algorithm, training and testing, these two phases are there. Training and testing. For example, in your class, your teacher is giving you training, and whenever you are writing your paper, that is nothing but your testing. Okay, what is that unseen data will come and you will just how you will solve it, that is testing. Okay, so in the if training is good, obviously you will get a good test result. If training is weak, so you will not get a good result in the testing. Same concept is there in the machine learning algorithm also. 1 minute. See, this kind of a data is there now. These are the features: name, rank, years, and tenure. These are the features, and this is the output. This is a permanent or not. Okay, if Ram, the rank is assistant professor, year is 3, is it tenure? No. Okay, Mary, assistant professor, year 7, then S. Okay, so this last always in the supervised learning algorithm, always last column is as your label only, output. Last column is your label. Okay, so this is output, and these are 3 features are there. In that features, name is there, rank is there, and number of experience in number of years is there. Okay, so this is the data. So you need to give the training to means with the help of machine learning model. You need to do this in training. In the training, okay. So this training data you have to give to the classification algorithm. Then classifier model. In that, see, n number of classification algorithms are there. For example, decision tree classification algorithm, etc., etc., C3, ID3, etc. classification algorithms are there. Okay. So how they will just classify it? If rank is a professor or year is greater than experience year is greater than 6, then he is a permanent. Yes. Tenure. Yes. These are the rules are there. Okay. In this way, we are constructing our model. Okay. This is the first phase in the classification. After that, then prediction. Once you train your model, means you have built your classifier. Then testing data is there. Testing data is unseen data. That Tom, Krishna, George, Joseph, and all this one is there. And again, see, in testing data is also labels are attached. Why this is so? Because we need to calculate the efficiency of our model. Okay. In testing data also labels are there. But what we are doing, we are just keeping that labels aside. In the testing data also labels are there. So we are just giving this kind of a name, rank and years only as an input to the test model, okay, to the classifier, okay. Then classifier will use labels for every record, and already we have that original records with original labels with you. Then we will compare that both the labels, whatever the labels given by model and whatever the initial labels are there, we'll just compare both the things. For example, 10 records are there, 10 labels we have, okay, and model will again predict the 10 labels. We'll just compare that this record, our label is S and model has also predicted S, this is the correct. Our label is no, but model predicted yes, then this is wrong. Okay, so out of 10, for example, whichever the 10 labels are there, if model will predict 7 correct labels, then we can say that it's a 70% accurate. Out of 10, if there are all 10 labels are correct, then we can say that model is 100% accurate. And once we have confidence that model is 100% accurate, then we can give this as a unseen data. See, in that unseen data labels are not there, only see Srinivas Professor 4. This thing is there only, Srinivas Professor 4. Then this unseen data, once we train the data, once we done the testing also, then classifier will give that output that S. He is a trainer S, he is a permanent. Because he is a professor also, number of year experience 4 is also, that's why he is a trainer is S. Are you getting it? Model training? Model training? Yes or no? Okay. See, decision tree induction algorithm is there. I just do that overview. What is the decision tree? In that decision tree, whichever these features are there. See, for example, what are the features are there in this example? Can you tell me? Is it visible? Last bench? Is it visible? What is this? Can you read this one?
Yes.
Huh? Read it now. Yellow color. हो मग तेच विचारते मी नाही नाही काहीतरी नाही ना दॅट्स वाय दिस एम्प्टी प्लेसेस आर देयर यू कॅन सिट हिअर ओके सी काहीतरी मीन्स इट्स अ फीचर्स येलो कलर मीन्स दिस इज अ फीचर्स एज इज देयर आफ्टर दॅट इन्कम इज देयर देन स्टुडंट क्रेडिट student is there, then credit ratio is there, after that your buys computer yes or no, these are the things are there, okay, these are the things are there, okay. So these are the features. Which are the features here? Age, income, student, then after that credit ratings, and in 4 features are there, and final one is that your label that buys computer yes or no, buys computer yes or no. This is your final label or final output. Okay, means you can say that if it's age is greater than equal to 30, income is high, okay, he is a student, no, he is not a student, okay, and his credit score, credit rating is S, then he cannot buy the computer, no, okay. But if for the S, okay, if his age is between 31 to 40, okay, his income is high, student credit, he is a student, no, okay, and his credit rating is also good, okay, then he can buy the computer yes, okay. In this way these records are there, okay. So this is your up to this one is your input, okay. These your features are age, income, student, and credit rating, and output is that buys computer. So tell me, it's a binary classification or multiple classification? Binary classification, because only 2 outputs are there, na. What are the 2 different types of classes? Yes or no. He will able to buy or not. Buys computer yes, buys computer no. Only 2 classes are there. Okay. And see, so in the decision tree, in this way tree will form. Okay. Whichever these features are there, out of that which one will become a root node. Okay. For that we need to calculate the entropy. Okay, we need to calculate the entropy of each attribute. We'll just call this thing as attribute only. Attributes are that your age, income, student, yes or no, and credit rating. These are the attributes are there. Then we need to calculate the entropy of each attribute. Entropy means it's called as uncertainty. मराठीमध्ये त्याला म्हणतात अनिश्चितता. Okay, you need to calculate as a uncertainty of every attribute. So some value you will get, a specific formula is there, okay. So that formula is there, and starting of that formula negative sign is there, that whatever the value always we want as a positive value, okay. Once that uncertainty means entropy of every attribute is there, whichever the attribute is having that highest entropy, based on that entropy will call as information gain also 1 minus that entropy. Whichever the attribute will have that highest information gain, that will become your root node. That will become your root node. Now see, in this here, three types are there. In the age also greater than 30, this type is there, less than 30, second is 31 to 40, okay, and less than 40. These are the three types are there, okay. This greater than 30, 31 to 14, 40. Now these are the three branches of that age. These are the three branches are there. Again, now for the remaining attribute, student, income, and credit rating, again we'll repeat the same thing. We'll calculate the entropy. Based on that entropy, we'll calculate the information gain. Out of that, which one is having that highest information gain, that will come here, the student, and all this one. I'll explain this example, and we'll solve we'll implement algorithm for this example. What is this example? It's a supervised, means labels are there, no? Labels are there, see last column labels are there. So it's a supervised classification algorithm. Supervised classification, because fixed classes are there. That's why it's a supervised classification algorithm is there. And as an output, we'll get this kind of a structure. In the program also we'll get this kind of a structure. We'll solve the same example. Okay? Now classification on the largest data set. So whenever you are going to classify, see in our previous, this is our data set. This is our data set. Only 14 records are there. 1, 2, 3, 4, 5, 6, 7, 8. Only 14 records are there. But it may happen that in some databases, okay, you will have a huge database, input database, in terms of lakh, in terms of gigabyte, and all this one. Okay. So in that case, you have to well see classification in large data set. So you need to consider that scalability also. Okay, see classification is a classification problem, scalability. What is scalability? See, scalability is a general term. Scalability is a general term. For example, I will implement one system. Okay, that system is working for 10 records very nicely. For example, I will do that your result analysis. Okay, result analysis, online result analysis. Okay, if up to that, whenever first student will enroll, he will get a result. No problem. 5 students will enroll, they will get a result. Okay, 10 students will enroll, they will get a result. But at the same time, if 100, 200, you are familiar with this one, you are not aware that SPPU website, whenever that result will come, so it will get, every time it gets hang for 1 day or 2 days something. That is just because of that they are not handling that scalability issue, that's why. Okay, so what is the scalability? Whatever your system is there, you have to do it so proper that if it's working for 10 users, same system without doing any changes should be work properly for 100 users also. Same system should be work properly without doing any problem for the 1 lakh users also. Then you can say that that system is a scalable system. Okay, so in machine learning also, see, in classification you need to take care of scalability. Classifying data sets within millions of examples and hundreds of attributes with a reasonable speed. Okay, so you have to take the care of that scalability. After that, why is decision tree induction is popular? Because easily you can able to identify the classes, and it's a convertible to simple and easy understanding classification. Can use that SQL queries and all that thing. So though you are first year, so you are not familiar with that SQL. Okay, so easily you can able to SQL queries for accessing database and all that thing. We can do it for classification. That's why classification is one of the famous learning model in machine learning. So next one is that regression. Second type of a supervised learning, regression. What is there in regression? Multiple outputs are there. Multiple outputs are there. See, this kind of a formula is there. This is there. Y-axis, X-axis. Okay, and this straight line is there. Anyone knows the equation for straight line? What is the equation for straight line? It was there in your 12th standard. Very good. Y is equal to mx plus c. Okay. What is that x? X is the x value. X value. M slope. And c constant value. Very good. Y is equal to mx plus c. Okay. That same equation we are going to apply for the regression here. Y is equal to mx plus c. See here. We just y is equal to mx. Here b1 is a m. B1 is a m. We just call that a b1 as m. And c means b0. Okay, see this straight line is there, You will just calculate a slope for this one in this way and this straight one. Means अशी एक line टाकावं लागेल आपल्याला, अशी एक लागेल. मग त्याची जी value is the m. Okay, and after that B0 means ही line जिथे interact होईल अशी इथे या y ला तो coefficient, constant value coefficient. X means A. So here now see, can you tell me that which is a dependent variable and independent variable here in this equation? Y काय असणार आहे? Very good. Why is it dependent variable? Because whatever the values of x you will put it, based on that you will get it a y values. So x is your independent variable and y is your dependent variable. Is it clear? Okay. Because see here, whatever the values of x, based on that you will get a value for y. Okay. So in this equation, y is a predict output. See, this y is our predicted out. Now we, in the term machine learning terms, how that equation will just interpret here. Y is your predicted output. Y is a predicted output and x is your input features. These features, just now आपण पाहिलं ना, input features, age, that income, student, credit score वगैरह वगैरह ते input features आहेत. Okay, so x is your input feature, b1 is a slope, b1 is a slope here, that y is equal to mx plus c, हेच लक्षात ठेवा, mx म्हणजे m म्हणजे slope आहे इथे b1, okay, and b0 is intercept or bias. Intercept म्हणजे ही लाईन y axis ला जिथे कुठे टच करेल त्याची जी व्हॅल्यू असेल, that is your b0 value. Is it clear? Okay, so in the regression, if we see these are the data points are there, and if we just draw a line considering that data lines, if straight line is there, then you can just call that this as a linear model. If you will get means plots all the point on the xy axis, whatever your input is there based on that, and draw the line considering that all the points. If you will get a straight line, then you can call that regression is a linear regression. Okay, if you will get this kind of a line, this kind of a line, okay, so that is your polynomial model. In the polynomial model, equation is that y is equal to b0 is multiple parameters are there. Here only b1 is there, na? Here b0, b1x plus b2x, b2x2 plus b3x plus b4x. These multiple parameters are there. That is called as a polynomial model. And if one parameter is there only and simple straight line you are getting in this format only, then that is your linear regression. Okay, so take x as the input data and all this. See, we will solve one example in the practical session for linear regression also. Okay, so that time your concept of classification and regression become very clear, and we will implement algorithm for the same also. Okay, now next learning model is that unsupervised learning. Yes, you are familiar with that unsupervised learning. Output labels are not there. You need to apply some methods, techniques, some knowledge. Based on that, you will get a labels. Unsupervised learning, customer grouping, data. See, mainly in the unsupervised learning, as a output, we are getting groups. Group 1, group 2 in this way, or group 1, group 2, group 3 in this way. Similar kind of people comes in one group. Similar kind of data comes in one group. Okay. Example for this one is that pattern recognition. Then after that your data compression, market analysis. These are the examples of your unsupervised learning. For example, suppose you collect data of customers with age, income and shopping behavior. This you have collected that their age also, income also, shopping behavior. What comes under that shopping behavior? What they are generally always means frequently what kind of things they are shopping. Okay, means for example, if ladies are there, then cosmetic products and all that things. If gents are there, it may be buying regarding something. Okay, that is called as a shopping behavior. Okay. Then, but do not know the customer type. You have this data, age, income and shopping behavior, but you don't know the customer type. So unsupervised learning will automatically form groups like high income frequent buyers, okay, then young budget shoppers, then occasional buyers. This grouping helps in targeted marketing. This is your unsupervised learning. In unsupervised learning, K-means algorithm also will also implement this K-mean algorithm in the practical session. Okay, K-means algorithm for unsupervised. These three things we are going to implement. One is that classification algorithm, then regression algorithm, and K-means as an unsupervised. In that K-means algorithm, it's an unsupervised clustering algorithm. Clustering means, what is my cluster? Cluster means it's form of groups of similar interest data items. Okay, for example, in your SPPU for paper checking there are 3 clusters are there. Pune region cluster, then some Nagar, whichever the colleges near to Nagar they have one cluster, whichever the colleges near to Nashik they have one cluster. So for the paper checking, faculties they are going to Nashik region, they are going to that Nashik cap. Sangamner Vegara, they are going to that their cap. Pune region wale, they are going to that which of the assigned colleges are there. So they are means SPQ forming the clusters. Okay, here cluster based on the distance. Cluster based on the distance. For example, for practical external also, okay, it's not possible that every time external will come from very far. Okay, so generally chairman is asking that for the means. BOS member is asking for the chairman external form cluster of particular colleges and just assign an external from that particular colleges to each other only. Okay, for example, it may happen that in your cluster based on that distance 10 colleges will come. So most frequently that you will get a external from the 10 colleges only in this way. Okay, cluster means similar type of data in one group is called as a cluster. For example, next semester, next year you will have electives. Elective subject means teachers will offer you, a class teacher will offer you 3 electives. Okay, so some for example DOS, then advanced security or some high performance network. Okay, some people will take that high performance network, some will take that DOS and some will take that security. So teacher will form a group of one security student, means it's a cluster. Similar kind of data in one item, one group. Okay, high performance वाले एक group में देना, दूसरा performance वाले एक है, and they will do the actions regarding to their electives only. Okay, so K-means is a unsupervised clustering algorithm. Is it clear? Cluster. We can age wise we can form a 3 cluster. Kids 1 cluster, young age 1 cluster, senior citizen means adult 1 cluster, and after senior citizen in 1 cluster in this way. Okay. So K-mean is an unsupervised clustering algorithm that groups unlabeled data into the K clusters. K means it's depend on your application now. K means number. It may be 2 clusters, then male and female clusters only. It may be 3 clusters, it may be 10 clusters. K is a number of clusters. So that points within the same cluster are more similar to each other than 2 points to other clusters. Okay. Then means each cluster is represented by the mean centroid. We'll solve this example. Its advantages, disadvantages. It's a simple and fast, scales well to do that large data set and limitations. Must choose that K before hand only. You should know that this is a K value and then only you will get it at K cluster. Okay. Then sensitive to initial centroids, sensitive to outliers only. Outliers means only, for example, in your cluster. Okay, in your colleges cluster, colleges are from your means nearest area means this is कुठले कुठले येतात मॅडम जवळपास इथलं सीट नगर वगैरे असं नगर वगैरे आणि some colleges from that Bombay. Okay, then that is outlier. That is okay. 10 colleges are there. They are within the 100 kilometer. And are some 1 or 2 colleges from Bombay, Karnataka. So that is outlier. Okay. Whatever that means, see what is that outlier? Sensitive to outlier. Outlier means vary from. It's not related to that particular group. It's called as an outlier. Okay. So K means is a sensitive to outlier and assume roughly spherical equal size clusters. Okay. Now second part in unsupervised learning. Main thing is that your unsupervised learning labels are not there. You have to apply your own knowledge, some behavior techniques, some methods, etc. And based on that, you are going to assume the labels for that all the records. Okay. So one of the important techniques you did it here, PCA, principal component analysis. Principal component analysis. Now just check this example. See here, this is my input, this is my data. How many records are there? 14. हे जे blue color चे ना 14 rows आहेत त्या. म्हणजे 14 records आहेत. 14 records आहेत. आणि किती features आहेत त्याला? Age, income, student आहे का नाही आणि credit rating. Okay, 4 features are there and 14 records are there. And this final one is that output. This data set is there. This is my data set that person will buy computer or not. This is my data set is there. First you imagine that just we'll continue that same example, supermarket example. In the supermarket example, you just imagine that if monthly supermarket data, how many customers visited supermarket? It may be 10,000, it may be 1 lakh or something. So 1 lakh records will be there. इथे जसे 14 rows आहेत ना तसे 1 lakh rows असणार. ओके आणि इथे किती ॲट्रिब्यूट्स आहेत आपले, इथे किती फीचर्स आहेत फक्त एज, इन्कम, स्टुडंट अँड क्रेडिट कार्ड. ओनली 4 features are there. In the supermarket example, first one is that category, cosmetic किंवा मेडिकल किंवा हेल्थ रिगार्डिंग वगैरह. आफ्टर दॅट देन ॲटम डिस्क्रिप्शन, ॲटम प्राइस, एन नंबर ऑफ थिंग्स, एन नंबर ऑफ एव्हरी कॅटेगरी, देन कॉस्मेटिक, देन this one. Okay, it may happen that instead of see here 200 columns असतात तिथे 200 to 50 columns. You just imagine that huge kind of data is there. 1 lakh rows आणि फॉर एक्झाम्पल 200 कॉलम. केवढं मोठं एक्सेल शीट बनेल ते इमेजिन करा. बरोबर आहे का नाही. अँड इफ विल गिव्ह दिस इनपुट टू द युअर ट्रेनिंग टू युअर अल्गोरिदम, हाऊ मच टाइम दॅट अल्गोरिदम विल टेक टू एक्झिक्यूट दॅट पर्टिक्युलर थिंग. बराबर आहे ना. ऑब्वियसली विल रिक्वायर लॉट ऑफ टाइम टू एक्झिक्यूट इट. ओके, जनरली वी आर टॉकिंग अबाउट here टाइम इफिशियन्सी देन. आणि स्पेस ऑल्सो, स्पेस इफिशियन्सी मीन्स हाऊ मच स्पेस इट विल रिक्वायर्ड in CPU also to execute all that things. Okay, so in that case what we'll do, we'll apply PCA, principal component analysis. Okay, what is that PCA? Principal component analysis means whichever the important features are there, so we'll apply some techniques. With the help of that, we'll only take the important feature and we'll execute our model with the help of important features only. This is called as a principal component analysis. For example, 200 attributes are there and 1000 records are there. It's okay. 1 lakh records are there. It's okay. Record will directly apply some formula vagara. Okay. Those who have taken items greater than 5000 only, so will less record. Will get a less record. Okay. And for that feature only, mainly PCA is for that features. We'll apply some techniques, and out of that 200 features, we'll just filter out only important feature as a 10 only. Okay, so 10 and some minimum rows, and then we'll implement our algorithm. Okay, this is called as a principal component analysis. Just take a real time example of that principal component analysis. Okay, for example, student has maths marks, okay, science mark, computer mark, and logical reasoning mark. So this shows that intelligence level. This all shows the intelligence level. So PCA compresses these 4 features into 1 or 2 main components only. PCA will just do some mathematical things, that matrix correlation, covariance, kutla vector to eigenvector and all these things. It was there in your maths na, in the 12th standard. Okay, eigenvector calculation, correlation and all this. Apply this one. Whatever that 4 columns are there, just turn it into that 1 column only. Okay, for the student only 1 score will be there then. So this is nothing but a principal component analysis. This 4 we turn it into that 1 only. Okay, it is called as a principal component analysis. Is it clear? Means that is for the dimensionality reduction. Dimension means your features are there. It's not possible for you to execute your model with the help of so many features. So you have to just take the important features only. You have to take the important features only. So out of 10 features, if 2 are important, so apply some, how we will consider these are the 2 important features. For that you need to apply some techniques. For example, you can calculate a covariance of that features. You have to calculate the eigenvalue, eigenvector and all that thing, and based on that you have to take the decision. Or mean, mode, median, these are some methods are there. Based on that you have to just find out which are the important features and execute your code with the help of important features only. Okay, so this is a PCA. So what are the applications of your unsupervised example? Customer segmentation, anomaly and fraud detection, cluster document images, dimensionality reduction. These are the applications are the recommendation systems, medical research, market basket analysis, social network analysis, image compression, etc., etc. Okay, now the last point of that last learning model is that your reinforcement learning. Okay, fourth point from that learning model, reinforcement learning. Yes, recall that reinforcement learning. Recall that which was the example we had seen in the starting. Okay, which was the action agent is there. He is taking action in the environment to get a maximum feedback, to get a maximum reward. Okay, see here, this agent means this dog is there, he will do some action, and based on that, this his boss will give some reward to him. Okay, so agent, environment, state, and action and reward. These are the things are there in that reinforcement learning. How it works, agent, I will skip this one now. Okay, and semi-supervised and supervised learning is just now I told that same thing. Which are your, for example, in the email classification, 1000 emails are labeled as a spam or not spam, and 50,000 labels are not are unlabeled. Semi-supervised means it's a combination of both labeled data as well as unlabeled data. Okay, means you have 51,000 records are there. 51,000 records are there. Out of 51,000, 1,000 emails are labeled as a spam or not spam, and 50,000 emails are unlabeled. So based on this 1,000 emails, you have to find some rules, patterns, and that pattern you have to apply on these 50,000 emails, and then you try to get some labels also for these 50,000 emails. So in this way, you will get total 51,000 labels, and give these 51,000 labels as input to your code, to your model. Okay, so what are the application of that your that speech recognition, medical imaging, text classification. Okay, see, along with that, say self-supervised learning model is also there. Self-supervised learning model, everywhere nowadays there is a use of self-supervised learning model. Self-supervised learning model means whatever the input is there, it will give the next output. Just are you familiar with that ChatGPT, BRT model? Whatever the things you are giving, okay, and after that whatever the answer you will get it, based on that they will just ask you that should I give the PPT for the same, should I give that MCQ model, should I give that question bank, all this one. Okay, this is means they predicted that if this is the input and whatever the output they have given, based on that it may happen that user will ask next thing, the same things also. This is nothing but your self-supervised learning. Okay, what is a self-supervised learning? See, self-supervised learning means amount of labeled data and large amount of unlabeled data is there. This is a powerful method used in a modern AI models like GPT, BRT, and image text model. The model generates automatic labels automatically from the data. Whichever the data is there, based on that it will generate the future labels. Okay, and reducing the need of a human annotation. Is it clear? This is your self-supervised learning. It's everywhere now. It's self-supervised learning. Okay. Now see, based on that artificial intelligence, after that machine learning, so these are the various algorithms are there, KNN, linear model, vagara. In unsupervised learning, PCA, then your clustering algorithm, KMS algorithm, all these things. In reinforcement learning, these are the various algorithms are there. That is, this is a complete one subject. Only this part. This is one subject. All this algorithm study and all that. Okay. Now ML model. We'll just go through that ML model. So these are the three learning methods. Five learning methods. Can you recall that? What are the five learning methods? Just now we have seen. First one is that supervised learning. Second one, chalo bolo patapat. Second one, unsupervised. Third one, semi-supervised and self-supervised also. So in ChatGPT, self-supervised has been used. Fourth one, reinforcement learning. Okay, so this your ML move around all these four methods only. Okay, some algorithm belongs to supervised, some algorithm this one, some algorithm this one, and that one. Then ML models. My topic for today is that your learning methods and ML models. Okay, so based on this learning method, specific ML models are there. What are these? So linear model, tree-based model, probabilistic model. Then after that, generative models, discriminative models. After that, parametric model, non-parametric model, then ensemble model, in which ensemble bagging, ensemble random forest, ensemble boosting. Okay, so we just go through that. Or is that diagram is visible for you? I think it's not possible for that backbenches. Linear models. See, ensemble model is nothing but your regression kind of model. You know, na regression, what kind of output you are getting is a straight line. Straight line means multiple outputs are there. In classification, only fixed classes are there. In the regression, multiple output. Just now we discussed that salary example. Na? That is nothing but the regression model where multiple output will come as an output. So, see here linear regression model, this kind of a graph you are getting it. This kind of a graph you are getting it. Okay. And what are these are this circle means this is are your data. Okay. And we have to just consider this data, we need to draw the line, okay, and after that this is your equation, y is equal to mx plus c. But here this is your polynomial regression. Why polynomial regression? Because your multiple factors are there. If it's only y is equal to mx plus c, okay, mx plus c, so only one parameter is there, that's why it's a linear regression. If multiple parameters are there, then it's a polynomial regression. Polynomial regression, see here parameters w1, w2, and this is your constant coefficient. Okay, so what are the types of linear model? Linear regression comes under here, logistic regression, Ries-Raschel regression, and all this comes under this model. It's okay, we should skip this one now, because at least at a 4 we'll start our this one, linear regression. Then tree-based model, okay, tree-based model, we discussed decision tree algorithm also. As an output, which are considering your features, it will consider based on that entropy and information gain, it will consider a root node, and after that it will draw for the remaining nodes as a leaf node and all that, and at the end you will get output of this one. This tree-based model. Tree-based model. This output you are getting as a in form of the tree. Tree means what are the tree parts are there? Roots, branches, and at the end leaf. Okay. What are the example of tree-based model? Decision tree model, random forest model, gradient boosted trees, etc. This kind of output. Probabilistic model. Can you see this diagram? Probabilistic model. Input data is there. Apply some algorithm, and you will get a class there. This is a class probability. This is B class probability. This is a class C probability. Class means if this, for example, 70%, then it comes under class A probability. You know na probability. For example, in your CET result, okay, if your score is more than 80%, then there is a probability that I'll get a good college. If score is more than 99.5%, then it's a probability that it's a 100% probability that I'll get a CVP college. Barabar hai na? Probability model. Whatever the output you will get, it means 99.5%. This is your score. So it's a probability that 100% probability you will get just checking my back result and all that thing and back whatever the scenario. So it's a 100% probability that I'll get a CVP college. This is nothing but a probability model. If your score is at 40% and you will try to think that, so it's a 0% that you will get a CVP college in this way. Probabilistic model. After that, generative models. Yes, it's also one of the buzzword now, generative model. You are familiar with that GAN, G-A-N, artificial neural network with the means this one. See, gen models, how data is generated. With the help of artificial intelligence, it's generating data, next data. Okay, so goal joint probability. An example navy based Gaussian mixture method, GAN, generative artificial intelligence. Is GAN. Generative artificial intelligence is a buzzword nowadays. Generative artificial intelligence. Okay. Then these are the generative models are there. After that, discriminative models that learns decision boundaries between the classes. If two classes are there, for example, pass and fail, these are the two classes are there. With the help of discriminative model, it will form a plane or line between the two classes. So pass, whatever the means inputs like that the students are having good marks and all, they will come into that pass category. If there are backlog and all that, they will come into the fail category. That is your discriminative models. Models that learn decision boundaries between the classes. Examples that logistic regression, SVM, neural network, etc. Discriminative model, okay. In generative model, this is a discriminative model, clearly line is there or plane is there, okay. And in generative model, separate clusters it will get formed. Parametric model means based on that parameters you will get output. Regression model comes under that your parametric model. In non-parametric model, see this one. K nearest neighbor comes, this kind of a graph will come. It will just form a cluster, nearest neighbor. For example, K is a 2, so whatever that values nearest to that 2 will come into that cluster. Okay, and after that, whatever the value very far from the 2 will go into that another cluster in this way. Ensemble model means you have to just combine various models for a good result. Means for example, model 1, model 2, model 3 combine and final prediction you will get it. Ensemble model means you have to combine it. Okay. See, multiple models or average result improves the accuracy and robustness. For example, if you will train your model and you are getting 70% accuracy, after so many iterations you are getting 70%, 70%, 70% only, and you are interested for 100%. Then you can try another model. Okay, it may happen that you will get 80%. If you try another model, and after that, whatever all the models are there, you have to combine it. Okay, and which are the important features of that all these things take it. It's called as ensemble model. See, ensemble model 1, model 2, model 3, combine it and final prediction. So multiple models on average results. Take an average of all the three things, that is your average result. Improves the accuracy and robustness. In ensemble model, there are three parts: either bagging, boosting, and random forest. Okay, what is that bagging? Bagging means train models in parallel. Okay, parallelly means, for example, you are training with about three models, different decision tree. After that, regression wala use kar rahe aap, or something different wala use kar rahe. All the three things will work parallelly, and then finally take an average of that all the three models result. That is nothing but the bagging. Train models in a parallel and bootstrap samples reduce the variance, and random forest is an example for this. Okay, boosting means model train sequentially, means first model whatever the output and whatever the experience, with the hope that it will give the input and it will boost the second model, then third model sequentially. It's called as a boosting. See, can you see the diagram here? Bagging means data, and these are the parallel. This model training and all, model 1, model 2, model 3 parallel, and take a average of all these things. This is your prediction result. Boosting, model 1 boost kara, then whatever that you give as a output as an input to that model 2, then model 3 sequentially, bagging and boosting. Random forest means, see, random forest training data instances, model training, and then model testing, and bagging means whatever that most bagging. Okay, which are that giving good result, consider that voting majority in prediction output. That this is nothing but a random forest algorithm. So summary, we can say that linear model means straight line logic, tree model means rule based thinking, probability means chance based decision. There is a chance. Okay, generative means creates a data. GAN is an example of generative. Discriminative means separate the classes. Ensemble means wisdom of crowds. Okay, based on that which model, which one will work, you have to take the output of that only. See, algorithms. Okay, now we have studied that learning types. We have seen models also. Okay, now you should have knowledge that for a particular application, which model you are going to apply. For particular application, which algorithm you are going to apply. See, whenever you will face for the campus interview. Okay, campus interview means your first way around you will get clear. For example, test and you whatever that you will get clear and all that. Okay, whenever that technical manager round will come. Okay, you know now what is the scenario now. So they will just give you some question. Competitive coding ka question they give you. Now you have to analyze that. Just obvious that question is not that in this way. Solve semi-supervised learning algorithm, this one using this one. Obviously that they will just give a situation. Based on that situation, whatever the wordings are there, you have to analyze that what kind of model will applicable for this one, what kind of model will give the good result in terms of efficiency also. Simultaneously, you have to consider that time complexity and space complexity also in the consideration. Okay, and then apply. For example, some kind of example is there, then you have to have, this will come into that graph model. Then graph wale algorithm आपको apply करना पड़ेगा. This will come into that, no, this will come into that, you have something sequential model. Then sequential model wale algorithm आपको apply करना पड़ेगा. Okay, so it's very important that algorithm selection strategy. Okay, if you just go through that some IIT and some good bits vagara question paper, just whenever you will have time, now just try to search it. IIT question paper. Directly straightforward questions are not there in their question paper. Situation is there, and based on situation solve the example. Okay, so if you will apply the correct algorithm, then only you will get a correct result. Na? But if you will not apply the correct algorithm, then what will happen? You will get a wrong result. That is not expected. Okay, so it's very, very important that algorithm selection strategy. So identify the problem type. You have to identify the problem type. Mainly in the machine learning, 9 problem types: tree based, regression based, classification based, parametric based, probability based, or non-parametric, discriminative. You have to just classify that this problem comes under which category. Okay, then identify the problem type, determining whether you need a classification or regression. Then analyze data characteristics, whatever the data is there into that problem. Just check that, consider the data size, set, feature type or complexity. For example, limited number of data is there, machine learning algorithm will work very nicely. But huge data is there, in that case you need to go for deep learning only. Okay, so this decision you have to take it. Then consider requirements. What are the requirements are there? Factor in interpretability needs, performance requirement and computational constraint. These are very important. Interviewer will not say that this one is there and that one. He will just give you a question. So you have to ask the question to him. Okay, so if then you will get to know that whatever your direction of thinking is correct or wrong. Okay, otherwise he will give a question and he will not able to identify that, and he will not ask some question. If you will not discuss that question with him, then you will not get a correct path to solve that example. Barabar hai na? So consider requirements. How these requirements you will get from that particular person. You have to ask that whether this one is there, this one is there. In the question paper, requirements are given directly. Then select appropriate algorithm. Choosing algorithm that naturally handle your problem types. Okay, because same problem we can solve with the, for example, if you just saw our PPTs, okay, health regarding problem we can solve with them for classification also, health regarding problem we can solve with them for unsupervised learning also, health regarding problem we can solve with that another method also. Okay, but again that health regarding problem, what is required, you have to check it, whether time complexity is required, whether some another thing is required, then along with that you have to decide the algorithm. Validate performance. Okay, then test multiple suitable algorithms to find the best performer. So model selection and performance. So what are the key goals are there? You have to assume that key goals in your mind and then you decide the algorithm. Okay. Choosing right model is very important. Nature of the problem, data characteristics. So business or practical constraint. Constraint means what is my constraints? Some limitation. For just take a simple example, constraint. For example, in bank account, whenever they will develop the program, okay, constraint is that always in that bank account at least minimum 1000 rupees should be there. So whenever you will develop a program, whenever you will write a SQL query, you will write a constraint that always amount should be greater than 1000 rupees. If you will do some trade transaction and with the help of that you are getting some amount less than 1000 rupees, so bank will find some penalty for you in this way. Constraint. Some constraints are there. So business or practical constraint you have to consider it. Examples, bias, variance, trade-off. These are the two things are there. Bias and variance. In machine learning algorithm, these are two very important things. Bias. Whenever you will solve the problem, always think of bias also. Bias means some error. Okay, assume that error will come and you have to consider that error. Just take a real-time example for example. What is that bias? For example, my college is 20 minutes far from my home. 20 minutes. Considering that traffic and all that thing, usually it needs 30 minutes to reach my college. Okay, actually it's a 7 minutes, 7 kilometer only, but means if you go ideally then it will take 20 minutes only, but I am assuming traffic also. So 30 minutes. So ideal time is 20 minutes, but I am assuming 30 minutes considering that traffic. So this 10 minutes, extra 10 minutes is nothing but the bias. Bias means error value. You have to consider error value. Whenever you design your model, consider that error value. Otherwise, means if you take very ideal condition, it may happen that your model will fail. Okay, and see, it's very simple. In the bias, I haven't considered that peak traffic time. It may happen that just because of peak traffic, I may get 1 hour late also, 2 hour late also. Considering that thing also. Okay. Bias and variance means error due to overly complex model causes overfitting. See, just because of bias it causes underfitting, and variance is causes see, these are also very important word, underfitting and overfitting. Okay, see what is that? Bias means error due to overly simple model. I have considered only the daily traffic. So initially 20 minutes I am without traffic, 20 minutes is the time to reach my home to college. Okay, and every day I am considering traffic as a 5 minutes only. It's a simple model, but it may happen that sometimes peak traffic will happen and it will take instead of 20 minutes it will need 60 minutes also, na? Okay, so error due to overly simple model is called as a bias, and variance means error due to overly complex model is called as overfitting. Underfitting and overfitting are related to bias. Do you think it's very heavy? Actually, just let it be. You are first year student. Just listen this word whenever you start your self study. Na, that you will automatically these examples you will get it, and you will means your study will become very simple. Whenever you will try to do your study on that time, you will become very simple. Okay, so variance means error due to overly complex model. Complex model, just example देखो अभी कि just nowadays which movie is there, that Dhurandhar movie is there, so going on. Okay, just by watching trailer, if my prediction is that no, it's very bad movie and it's a too lengthy movie and it's too much fighting is there. Okay, this is my prediction. Okay, so this is called as a variance. Error due to overly complex model. Complex model means I have watched only the trailer, and just based on that trailer I am doing this prediction. Okay, so this is called as a variance. Okay, so it causes the overfitting. Okay, but if I watch that full movie, then I can say that no, it's a good movie and all that thing. बराबर है ना? चलो, so overfitting. See, overfitting is classification. These are blue color means one class, and this violet color is another class. Overfitting, try to fit each and everything, and this kind of a line you will get it. In balance fitting, equal, this one. Underfitting, see, this line is going down. Underfitting is too many one class problem into that another class problem into this one. See, in regression also this is called as overfitting. Balance means equally, and underfitting means some outlines are also there. Is it okay? If we take an overfitting, underfitting problem, it will take near about 30 minutes to solve it. Okay, but these two words are there, overfitting and underfitting. Underfitting means, see here, for example, if we predict the student marks, the student marks also depend only using student performance using only attendance. This is underfitting. If attendance is low, definitely will get a fail. This is called as underfitting. Okay, but see, along with that, other parameters are also there, na? Study hours, teaching quality, his health. Ignoring all these things, if we directly move to the conclusion based on attendance, then this is underfitting. Okay. After that, overfitting means the student memorize answers instead of understanding concepts and scores high in a practice test. Okay, but fails in an actual exam when questions challenges. This is called as overfitting. Okay, means some student he is very hardworking, he memorized all this one, he memorized all this thing, and in his unit test he is scoring out of out marks. Okay, out of out marks, but in the final exam if there is a change in the question, okay, so he will get failed. So this is called as overfitting. मैंने उसको बहुत ज़्यादा ही hype कर दिया था कि unit test में he got very good mark, he is a very good student, he got very good mark, he is a very good student, but that is not a case. Okay. So this is all about that theory part. Now we will move to the practical session. We'll just take it one practical at least in proper way. So with the help of that easily you will able to, machine learning practicals are very simple. Easily you will able to implement another algorithm. What we will do? We will do with the help of Colab. Are you familiar with that Colab programming? It's a facility given by Google. Okay, so you have to just open that your any Gmail account, open the drive, and you just type it there Google Colab. Okay, so one file will come here. Environment means Google is giving that environment to run the machine learning programs. Otherwise, you can use a Jupyter Vega also. But again, I don't know that Jupyter has been installed on the machine or not. So we'll go for Google Colab. So simultaneously, I'll write some code. Simultaneously, you have to write the code, and then we'll see that output. What kind of output? We'll just do it for that credit card, buys computer वाला example करते हैं. Okay, that code will write it for that. सुपरवाइज वाला वो करते हैं, अनसुपरवाइज वाला हम के मींस का करते हैं, वो रिग्रेशन वाला हाउस प्रेडिक्शन का. बट आई डोंट नो, दे आस्क्ड मी टू स्टॉप अप टू 4:30, so how much time will get it? At least we'll execute one assignment properly. चलो, so thank you for patience listening.